Okay, let's get an expression for the length of a tangent line from an external point. So if we have external point B with coordinate x1, y1, and the center of the circle HK. So we want to get AB given the radius and the external point. So if we join OA and OB, we have this. And if we call OA, is our radius. This is the radius. And we know radius is always perpendicular to the tangent line. So this is perpendicular to that. And let's call this D. YABL. That's what we are to find. So using our Pythagorean theorem, we can see that Pythagorean theorem states that r squared plus l squared must give us d squared. That's Pythagorean theorem. So our main aim is to find L. So L is now the square root of d squared minus r squared. But if you look at d squared is the distance. That's d is the distance between H, the center, we coordinate HK, and the other external point. So, but you see that d squared is equal to x1 minus h all squared plus y1 minus k all squared. That's distance between 2 points. Distance formula. So we can easily see that therefore what we are looking for, L, is square root of x1 minus h all squared plus y1 minus k all squared minus r squared. So where, at least that's the formula. So once you know where h comma k is the center, r is the radius, and x1, y1 is the external point. So look at this question. We also find the length of tangent to a circle with center, that, and radius 5 from the external point 7,3. So we've proved that the length of tangent L is always square root x1 minus h all squared plus y1 minus k all squared minus r squared, where L is the length of tangent line, h comma k is the center of the circle, x1 comma y1 is the external point of the circle, yr is the radius. So let's substitute. We've proved that. Okay, see the diagram. So you can see the external point. So from Pythagorean theorem, we have to get L, which is the length of tangent line. So this is the radius, this is the center. So D, using distance formula, you see that d squared is this. And from Pythagorean theorem, if you sum the square of the radius and the length, we get the distance squared. So making the length the subject of formula, that's how we'll use square root d square minus r square. So we'll substitute d square using distance formula. So that's how we got it. So let's finish up. So we'll substitute. Therefore L is now x. So these are x1, y1. Y this is our h comma k. So we now have that square root x1 is 7 minus 1 squared plus 3 minus 2 squared minus 5 squared. So which is square root of this 36 plus 1 minus 25. This 37 minus that is 12. And we know that 12 is 4 times 3, so we have 2 root 3. So our answer is option B. So very tricky question. Thank you.